due to spin. As we know that an electron is spinning about its own axis, okay? We already told you that once electron moving in an orbit, then there are two types of motion. One is orbital motion, and the other motion is its motion about its own axis, like the spinning of electron. So it means that due to this spinning, there is a tiny magnet and possesses a magnetic moment also due to this spin. But we know that we know nothing about the shape of electron or the manner in which its charge is distributed. How the charges are distributed and how is the shape of the electron. So it is impossible to calculate the spin magnetic moment like the way we calculated for the orbital motion of electron. So that's why, like, in order to obtain the agreement with the experimental result, we have some experimental result for the spinning magnetic moment due to spin of electron. So in order to make a correspondence between the experimental result and the theoretical results, the magnetic moment which was directly written for the spin of electron without any proof was found to be minus 2 times E over 2 mc into P of S. This was the analytical expression, like without any proof. They just wrote this relation just to make the theoretical and experimental result equivalent. So these results or this equation satisfy the experimental results. There is no proof of this equation because we don't know the shape as well as the distribution of charge in electron. And that's why we can't derive a proper relation what we did for the orbital angular magnetic moment. So there is a direct analytical relation and result which was written like this, where PS is the angular momentum due to spin of electron, and we know that PS is S into h bar. So if I put it in above equation, we get mu s, which is equal to 2 E S h bar divided by 2 mc. I'm not writing the negative sign here because it just represents the rotation that this is for the electron. Now we know that the spin is either up or down, so its value is 1/2. So this implies that this magnetic moment due to spin of electron is 2 E h bar over 4 mc. If we simplify it to cancel with this, so we have mu s, which is equal to E h bar over 2 mc. And this is the value of Bohr magneton. This is equal to Bohr magneton, MB. So here we can write it is like we have this magnetic moment due to spin, which is equal to E h bar over 2 mc, which is equal to Bohr magneton. So magnetic moment due to spin is equal to exactly the value of 1 Bohr magneton. Also, according to wave mechanics, we have S, which is equal to S into S plus 1. Okay, we replace P of S by SH bar in the above equation. So in wave mechanics, this P of S is S into S plus 1 square root H bar. So we have replaced this S, which is here, this S1, S, by this relation. So S is equal to S into S plus 1 in wave mechanics. Also we know that S is 1 over 2, So this S, I call it S steric. This S steric is 1 over 2 into 1 over 2 plus 1 square root, and its value is around square root 3 divided by 2. So I'm starting from this equation again. So mu s will be equal to 2s steric E h bar over 2mc. So if I put the value of 2, and s steric is square root 3 over 2. Square root 3 over 2 E h bar over 2mc. So if we simplify it, these 2 cancel with these 2. So we have square root 3 E h bar over 2mc, which is equal to square root 3 times Bohr magneton mu s. So this is the difference between the value of magnetic moment due to spins by using the quantum mechanical, by using the classical approach, as well as by using the wave mechanical approach. So this is all about magnetic moment due to spin of electron. Next we will discuss different quantum numbers. So I think it's better to discuss in the next video. Thank you.